Hi, thanks so much for having me. And I'm going to tell you a bit about my background and what I'm thinking about these days and what I think is really important. So, I've spent the last 20 years doing research in astrophysics, looking at beautiful images like this, and doing data analysis to learn about dark matter and dark energy that seem to make up most of our universe. Um, and so what has that got to do with you? Well, it turns out that there's lots of other things important in the world other than astrophysics and cosmology, which I've been doing for the last 20 years. But I also was very grateful and lucky to have this David Mackay on this slide here as a mentor when I first went to university to study natural sciences. And he wrote a very influential book called Sustainable Energy. He went on to write a very influential book called Sustainable Energy Without the Hot Air, which was all about different energy sources and how they contribute to climate change and how we can try to address the amount of energy that comes from fossil fuels. And that really led me to start thinking about this topic, particularly when I bumped into him and it turned out that he had terminal stomach cancer, and very sadly he died about 5 years ago. And it made me really think about the future and really whether I was doing the right thing with my life, and what are the most important things that we should be doing today. And that really led me to climate change. And I'm sure I don't need to tell you about the importance of climate change. I guess I was thinking about my kids starting school and starting to think about, what would the future like be for them, and what would they say? What would I say when they ask me, "What did you do about climate change, Mummy, in 20 years' time?" And I say, "I looked at the sky. I decided I really need to do something." So, starting to think about the Earth rather than the stars. And you may be familiar with this beautiful graphic showing the average temperature each year since 1850. And so, if you're talking to somebody who's maybe a climate change denier or something, then you might say, "Do you think it's bluer on the left-hand side than the right-hand side?" And there's less of a sort of a discussion once you look at it like this. I tend to find it definitely looks redder on the right-hand side to me. And even if you don't think that it's getting warmer, we definitely measure the amount of carbon dioxide is increasing, and so that using the basic physics of absorption by different molecules in the atmosphere is going to cause warming in the future. But actually, when you look at this, about a quarter of all greenhouse gas emissions, about a quarter of all climate change is coming from food. And that's really a really fascinating topic because we all have to eat, and there's many fascinating bio kind of challenges within producing food. And so, we can start to then look at different things that you might eat, different foods that are produced, and think about how they're made and how we can try to reduce greenhouse gas emissions from those foods. I expect you can probably guess the answer to this question: which causes more climate change, out of an 8-ounce steak or a microwaved potato and beans? But just to show you the difference between those two things, you can see there that it's more than 20 times different. So at the moment, with the current way that we produce beef, then it's the largest greenhouse gas emissions kind of product that people normally consume per gram of product. But there's lots of interesting bio challenges there. A large fraction of that comes from microbes in the gut of the cow. And there's lots of different research on different additives you could put in the feed of the cow that would help to reduce the greenhouse gas emissions. If you're looking at also animal feeds in general, then animal feeds for things like chicken and pigs, that tends to dominate the emissions from producing pork and chicken. And so if we can then look at different types of food, so there's projects looking at growing algae in deserts, in big vats containing water. How can we produce food that animals can eat, even if we don't want to eat algae or duckweed, as some of the research is about? Then is there things that we can produce that animals could eat that would reduce deforestation, which is also driving food emissions? So there's lots of really interesting challenges there. But if we want to produce more food for us or for animals, then it's going to come down to plants eventually. And when we grow food like potatoes in the field, then a large part of those emissions are coming from fertilizers, because fertilizers interact with microbes in the soil, which then produce nitrous oxide, which is about 300 times more powerful in causing global warming than carbon dioxide. So there's a huge difference between, if we could get these microbes which are in the guts of cows, or the microbes that are in the soil, there's some really fascinating challenges which are really at the root of the reason why food contributes to climate change at the moment. Just a bit of fun to look at some other examples here. So which do you think causes the most greenhouse gas emissions out of these options? You've got a bowl of cereal there, or a latte with milk in that, obviously, and coffee, or a couple of boiled eggs. Obviously, it depends really how big the latte is and the bowl of cereal. So if you look at the numbers here, you can see that a latte is if you've got 500 grams of milk in that compared to 200 grams of milk in your cereal, that's really, really what comes down to the importance there. And then again, we're coming back to cows and microbes in the guts of cows. A sandwich, you can look at different sandwich options, chicken sandwich, cheese sandwich, or a nut butter sandwich. And again, we're looking at really the chicken and the cheese there being the biggest contributors. And we're back to how are we feeding those chickens, and how is the manure managed for those chickens? Are there ways of maybe treating manure differently that would also reduce emissions, and how we can feed those chickens in a way that causes less deforestation. So there's lots of interesting challenges there. Actually, all these graphs are just the same scale. If we look at snacks, it's not a big difference. So we won't worry, we don't need to worry so much about the transportation if it's by ship. On the other hand, if we're looking at something like this for dinner, maybe a chicken curry or spaghetti bolognese or fish and chips, you've probably guessed already that the beef in the spaghetti bolognese is the biggest one of those things. But actually going to catch fish at sea, so the diesel that's used to run the fishing boats to go and catch fish at sea, or the food that's fed to fish on fish farms is the main cause of the emissions for the fish. So different options, different issues, but this actually, the dinner time one is actually more important than all the meals that we looked at already. So you can read more about this in this book if you want to. It's free online, or you can go to our website to download our free materials that we're playing around with, producing things for people to play. So you can play the Climate Food Challenge game here, or you can download these flashcards, play with those if you want to do that. We're also doing this for different countries and different groups, different schools, and also trying to really have a dialogue. I think, science is great because we can do lots of new technology, new things we can do with it. But actually, I think a large amount of the climate change issues we're facing now is about how we communicate with each other and get uptake of these new technologies, but also how we're actually going to engage all the different people that are producing food in the conversation about how food contributes to climate change, which will then hopefully stimulate more interest in new solutions and help to solve the problem. So this is really about getting everybody involved in the conversation. These videos are aimed at kids, but actually there's interviews there and conversations with, for example, Harriet Henrik, who's the livestock lead at the NFU, National Farmers Union in the UK, thinking about how we can do calculations to work out how much emissions are done on farm, for example. And you can even do calculations at home just to work out how different things add up to contribute to climate change from different foods, and kids here doing some of these calculations, starting to make some of these diagrams I showed you on the other slides. So there's a lot that we can do. You can find out more on the website if you want to do that sort of thing. But really, I think it comes down to, for me, in looking into the future, my personal sort of goal, my sort of passion is, how do we help to reduce greenhouse gas emissions from food? And how do we make that information more available to people? So there's interesting data science challenges there, and how do we get people all talking about this and trying to work together to come up with solutions. And some of that is going to involve better self-sufficiency as we have to adapt to climate change. So looking at, for example, how do we grow more food locally to get that more accessible to people, And certainly with coronavirus, the COVID-19, over the last few months, there's been a lot more interest in how do we increase self-sufficiency and resilience to different events that might happen that might disrupt our food supply. And I think there's some really, really interesting challenges there as well. So thank you very much for listening, and I'm really looking forward to talking with you and answering some of your questions. Thanks very much.